Okay, so diagnostic drill number 2. If you want to, let's take a piece of paper. I'm just going to go over some basic things that you're going to want to look out for, basic ideas of what to look or what to understand, because if you understand these things, you have a shortcut right away to take, okay? I'm going to go through them, just 1, 2, 3, 4 really quickly, so that way you know how to do everything across. Does that make sense? You know how to do it 1, 2, and 3 ABC. Or, yeah, ABC of number 1, and then ABC of number 2. So, ABC for number 1, right away what you can see is this is dealing with mean, median, mode, statistics, right? So, mean is average, so add everything up, divide by the total number. Number 2, median is the one right in the middle, because a median of a highway splits the number of lanes exactly half and half. Mode is the one that shows up the most, and range is highest minus lowest to find how big the gap is between the smallest to the biggest numbers. Now, what are the things that you got to look out for? The first thing that you want to look out for is at the top you got to see how many total terms they give you, because the even or odd number of terms determines if that average is able to be, or determines if that median is able to be found without having to do an average. Does that make sense? If we have an odd number of terms, there's something right in the middle, because there's even on both sides, or there's an even matchup for both sides that leaves an odd in the middle. However, if we have even, there's going to be 2 numbers in the middle that we have to average out. Okay? So like in this first one, they tell you like the median is already at 0, but they gave you an even number of terms. So that means D plus E have to equal 0. Okay, does that make sense? Yeah. And so we got to go through and come up with whether or not ABC or combinations of those are true. Okay? So if the mean is 0, and we have a even or even an odd number of terms in this situation, we have to understand that the 2 different sides of that, the positive and negatives, end up canceling each other out. Does that make sense?
Yeah,
Right? If it's a mean, that means that, or the average of it all ends up being 0, it's pretty much all the numbers end up canceling each other out to give yourself a 0. Because if you ended up dividing by anything other than a 0, you end up with a value, so it wouldn't be a mean of 0. Okay? So we'll go through these after. Okay, but number 2, anytime you see a parabola, you got to have all the thoughts of what a parabola should make you think of. Okay? Everything that should come to mind when it comes to a parabola.
Vertex.
Vertex. Vertex also gives you axis of symmetry, right? The fact that along that axis of symmetry, anything on the left is the same as the right if you have the same number of steps from the middle, from that axis. Going up or going down has just to do with the x squared at the front. If the a in front of that is a positive or negative, you go up or you go down. You have your shifting left and right, shifting up and down, that you should understand. You have your perfect squares and difference of squares that help you shift your graphs as well. I'll show you the little sheet or the study guide in a moment that gives you all of that. But for example, they love to do this where they give you a parabola that tells you, let's say the maximum is at f at 12. What is equal to f of 16? Well, it's 4 over from that 12 to get to the 16. It's got to go 4 over or 4 back. So it's going to be f of 8 that is equal to f of 16 here, because what you have is you have the 12 in the middle, that's the maximum. You've got 4 over to 16, then you got another 4 over back to get to your 8. So f of 8 has to be that as well. That make sense? Yeah. Okay. So, and then if you have f of 14 equals f of 20, then you just got to go between, you see there's a distance of 6 between them. So it's a 3 and 3 on both sides. So it's going to be f of 17 that gives you that middle, or the maximum or minimum. You don't know, but that's the vertex. Okay. So you see how quick and easy that is? Yeah. Then you have your formulas for your vertex and your axis of symmetry, negative b over 2a, which is directly linked into your quadratic formula. Did you know that? Write down your quadratic formula for me real quick. What I want you to realize is there's 2 parts to the quadratic formula. What you have is you have the vertex spot And then what you have is you have the addition and subtraction to find your zeros. Your addition and subtraction of your discriminant determines how many real numbers you end up with, and determines what the discriminant, this discriminant determines how many values you touch or go across on that x-axis, okay? However, that negative b over 2a at the very front, I like to think of that as the vertex, because that shifts wherever you end up going. And so knowing that, like in C, number 2, they give you A, B, and C. A is 2, B is B, C is a negative 37. You plug those into your negative b over 2a, right? And you know that's going to be where the middle, or where the vertex is supposed to be. If a parabola is 9 is equal to at 9 is equal to 21, right? That's a distance of 12, so a distance of 6 between. F of 15 is where the vertex is. So 15 is equal to negative b over 2a. I can solve for b now.
Oh, yeah.
You see that?
Yeah.
So it's a way to go back and determine what the values are, because you have a solid conceptual knowledge of what this parabola is asking of you. Now, what you should also notice is in a lot of these problems, they like to misdirect you, if that makes sense. So, which of the following is equal to f of 16? Simply because you're so used to having formulas, a lot of kids look at this and say, okay, well, all I know is it's a parabola. I don't have the parabola. I don't know what to do anymore, okay? And so don't let yourself get caught up in that situation, because all this is a conceptual knowledge of what the graph is supposed to look like and how things shift around for yourself, okay? Number 3. This one I think it looks tough, but it's really not as bad as it looks, because what you can do is you can go and you can take your numbers and you can order them out for yourself. If you were just to say 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, that gets really, really hard to deal with. But if I took this and I can create 2, 2, 3, 3, 3, 4, 4, 4, 4, right? You can deal with the numbers later. So it's like, if I go up to 68, and there's 68 of these, right? So I know 68 times 68 is the value of what's in here, right? Then I have 69 over to 69, and if they say stop at 70, first instance of this, well, then there's only 67 of these values in there. That makes sense?
Why would it be 67?
What I'm trying to say is they like to say, okay, what is the value, or how many numbers reside between these?
Oh, okay.
Okay?
Yeah.
Or they like to say, add up the numbers between 68, the first number of 68, to the first number of 70. Add all the numbers up. Well, then you would have to come up with an equation and be able to visualize what exactly are the numbers you're adding together without confusing yourself, because this is hard to deal with when you go across.
Yeah.
When you order yourself out to a much more visual, like a pattern that you can actually visualize, it's a lot easier to deal with that answer. Right? Okay? Next page. Is a 99% problem. A 99% problem is something that you're doing just about everything. Sometimes you even do too much. Like this could technically be what I would consider a 101% problem. You do too much. Okay? You go and you solve for x, and then they come back and ask you x equal x to the third. And you don't answer that, because what if x is a 2 and x to the third is an 8? Do you see how it's possible for you to miscalculate and answer A if you jump to conclusions right away, like people normally do? Do you see how B is trickier than it looks? Simply because you have two directions you can go. You could do too much, you third root that x and you find x, and then you go get the wrong answer because of that. So that's like a 99 and 101% problem. You go too far and then you don't answer the actual question, so you don't take the last step you needed. But that last step that you took was technically more than you needed, because you found an x to the third already in there. Okay? So C is even more so. Do you see that? It's very likely that you're going to end up with something in a parentheses somewhere squared, and it's just going to be a value that you solve right away for. Okay? So a lot of these ones, it's more like solve for this new variable. Be careful. You're not just x, not just r, just y. You're solving for a different thing, so keep your eyes a little bit more open for that, and that's going to make the difference on your test right away. Okay? 7, next page. Number 7, it's really not that hard. It's that symbol problem. They love to give you symbols that represent functions, and simply because you haven't seen it this way before, your mind starts to go into overdrive and you're not sure what to do. In this situation, all you got to do is replace that symbol with a function. Okay? So right on your test right there, right on your worksheet, right where that sun is, I want you to write f of m instead. That makes sense? F of m is 3m over 2m minus 5. Do you see that? Now, is f of 4 greater than f of 5? Is f of 4 plus f of 7 equal to 10 times this? I think we flipped the value on that, right? But if it's 10 times that, then do you see how, right? That should be function of 10. Function of 12 divided by function of 4, is that equal to function of 3? Do you see that? And so what could you do? You could plug in 3m over 2m minus 5 in your calculator to graph and find your values of 4, 5, 3, 7, 10, and use those numbers to determine your final answer. Okay? What's the most common mistake that comes up on this type of problem?
People probably multiply 3 to the 3m over 2m minus 5.
Yes, they multiply things wrong, and another really easy mistake is, let's say, for example, notice in your answers, they're all functions. It's often that because you're not used to seeing that sun function in front of it, you mistake it. So let's say 3m over 2m minus 5 somehow equals a 7. And you have a sun of 7 on the bottom. A sun of 7 needs to be plugged back into that equation, is actually 21 over 9. Do you see that? So the f of 7, right, or f of the function that you have, that 7, is not equal to it.
Right.
Okay, that makes sense?
Yeah.
So don't mistake your value for your equation here. That makes sense? They love to trick you with this one.